Hey guys, this is Miss Adams again. Let's go through our 3.1 practice. So it says to evaluate the following expressions given the functions below. Write the ordered pair represented. So I've given you m of x equals 2x plus 7. I've given you that our input here is negative 6. So that means anywhere where we see an x, we're going to substitute in the value of negative 6. So I'm going to have 2 times negative 6 plus 7. Well, 2 times negative 6 is going to give me negative 12 plus 7. And negative 12 plus 7 is going to equal negative 5. So that's our output value. So where m was equal to negative 6, we had an output value of negative 5. And this gives us the ordered pair negative 6, negative 5. Let's look at when our function of x equals x squared minus 3, and we're told to evaluate it when our input value is 4. That means when our x value is 4, so anywhere we see an x, we're going to plug in the value 4. So now I've got 4 squared minus 3. Well, I know that 4 squared is 16. So I know my f at 4 is 16 minus 3, which means my function at the input 4 is equal to 13. So my independent variable was 4. My dependent variable was 13, meaning my x value is 4. My y value is 13. And now let's look at k of x equals negative 5x plus 9. And I'm going to use our input value of 8. So anywhere we see an x, we're going to input our value of 8. So now I can say that negative 5 multiplied by 8 plus 9 is going to equal my function, so k, evaluated at 8. Negative 5 times 8 is going to give me negative 40 plus 9, which will give us a value at k of 8 is equal to negative 31. Our input value was 8, our output value was negative 31, which means our x was 8, our y was negative 31. Alright, so let's look at this problem. So it says if f of x equals negative 3x plus 6, find the x for the given expressions below. Then write the ordered pair represented. So now I'm going to set my function of x equal to 0. So I know my output then is 0. So I'm going to say that 0 is equal to negative 3x plus 6. And I'm going to solve for x. I'm going to do the subtraction property of equality to isolate my variable term. I now have negative 6 equals negative 3x. And I'm going to do the division property of equality to isolate my variable to get that x is equal to positive 2. So when our function of x equals 0, we're going to be at the point 2, 0. Let's look at when f of x equals 15. So that's our output value is 15. So I can say that 15 is equal to negative 3x plus 6. And now I just have to solve for the variable x. My first step is going to be subtract 6 from both sides, using my subtraction property of equality. 15 minus 6 is going to give me 9, and 9 equals 3x, negative 3x. And then my last step is going to be to divide by negative 3 to isolate x to where x also equals negative 3. Alright, let's look at this last one. We're told that f of x equals negative 27. So our output is negative 27. And we're trying to find our input value of x. So I can write this as negative 27 is equal to negative 3x plus 6. The first thing we're going to do is subtract 6 on both sides. So I'm going to get that negative 33 is equal to negative 3x. Then I want to isolate my x variable. So I'm going to divide by both sides by negative 3. So x equals positive 11. So we have the ordered pair 11, negative 27. Alright, let's use the graph of g of x to find the following situations. Alright, so we're looking where g, and we have an input of negative 2. Alright, so if our input is negative 2, that means our x value is negative 2. So we're going to be at the point negative 2, 3. So if our input is negative 2, our output is 3. So we're going to have the ordered pair negative 2, 3. Alright, if I look where g and an input of 0, well, I've got an input of 0 right here. That means I haven't moved any on my x-axis. So that means that my x value is 0. And my y value then is 1. So we're at the point 0, 1. And if we're evaluating our function g at the input 4, we're going to be right down here at 4, negative 3 with an input value or an x value of 4 and an output value of negative 3. Alright, let's look at this graph. I'm now telling you that g of x is equal to 5. Alright, and once again, Ms. Adams has made another typo here. You should be thinking that your output value is your y value. So we're missing our x, but we're given that the y value is 5. So if our y value is 5, hey, we've got a point here with y value of 5 at negative 4, 5. So our x value then is negative 4. So we've got the ordered pair negative 4, 5. Let's find when our g of x is equal to 3. So that means our y value equals 3. Well, it looks like we're at the point negative 2, 3, giving us an input of negative 2. And our output is positive 3. And then if I look at our function g of x is equal to negative 1, that means our y value is negative 1. So we're going to be at the point 2, negative 1. So I know that my y value is negative 1, and our x value then there is at 2. Alright, and then let's look at this table. So given the chart below, find f or your function of x. So if I tell you that f of 3, that means our x value is 3. Wherever our x value is 3, well, in this case, looking at the chart, the y value is 7. So then I'm going to have the ordered pair 3, 7. If I'm looking at a function of 2, with an input of 2, that means I'm finding that function at the point 2. Well, I've got 2, negative 5. So my output value is negative 5, which means the ordered pair here is 2, negative 5. Now, if I have a y value of negative 5, which means I have an output of negative 5, well, if I'm looking at my y's, I have an output at negative 5. That means I have an input here at positive 2, and I had the ordered pair 2, negative 5. Then if I'm looking again for an output of f of x equals 19, that means my y value equals 19, my x value equals 4, where y equals 19. So that's going to be the ordered pair 4, 19. Alright guys, that's all we have for lesson 3.1. Go ahead and get started on that homework.